Oh, you guys are not. That's kind of fun. I think I could just give you. Uh, let's do that real fast. Ba, ba, ba. That is so weird. Why is that not working? All right. Oh, it's because I don't have a source. There we go. There it is. Okay, cool. Sorry, I was messing around with OBS this weekend, and it clearly shows. All right, so the back to what we were saying. So the big stuff that we've been working on is I added argument parsing. It works for the most part, and we'll get to why the for the most part. Um, we added, restructured this PDB reader. So this one basically does it so that we can just skip non-atom lines because, like, for most use cases, we don't care. I've noticed that there is a little bit of analysis that does care about it, but we'll come to that when we get to it. Also, we're going to talk about the next generation of this project. I found a new file type that we're going to parse. It's a binary file type that is Fortran formatted, baby. We're doing something fun today. Or not today, but we will soon. um, other things that we added, testing. So basically, I figured out that this was actually not parsing correctly. So we added inline tests. So this allows you to, put in a line. We can parse out the lines to validate that everything looks good. What else? Atom records are. I'm working on writing a way to stringify it into JSON. So this will create a JSON. I can kind of show you. It gets kind of crazy. So we can do a zig test, source main.zig, and we'll get a JSON file. As you can see, there are a couple points where we're getting like weird strings back, and that's mainly because, let me zoom in a little bit. So Control Shift, hold on, plus. Hello, keyboard. Oh, it's that one. Yep. Control. There we go. That should be a little better. So if we do this, it as you can see, there's like some weird characters that pop in here. So like this charge and the element. That's basically because they're not set. So what happens is they just get assigned just random memory, just random whatever we come up with. So that's kind of where we run into this issue. But as you can see, we do get a nice JSON formatted. I don't think we really need it, but it is cool that we can add it. Um, we're going to see if we can compile it into WASM at some point, just to see if we can. The other big thing, actually, that we changed, and this is kind of the one that was really cool, we're actually using two different allocators now. I think I can actually pass this one here. So GPA. Let's see. It's just allocator, I think. So I think I can pass in. Let's see. Yes. Um, so the biggest change that I made was we switched to an arena allocator. So what that means is it allocates a chunk, and then we call one free at the end, and then that free frees everything. So before we would have to deallocate. We'd like allocate for the file, and then like deallocate the file when we're done. And now we just give it a bunch of memory at once because the reality is that reading an entire file in a memory is going to be a lot bigger than not than anything else we're going to do. So that's kind of the thought. Um, that's actually wrong. This should be oh yeah. But this is like much cleaner than what it was. This should allow us to do stuff a little bit more simpler, like a little bit more simply. So we have, this kind of parsing of arguments, testing. Basically, what I want to do is I want to move the atom stuff separately, and then the main file will just be for main. So, yep, that's the thought. But yeah. Let's see. Yeah. Also, we're adding comments. We're making it look pretty. We can get rid of this. And then we actually did something cool too. We did CSV writing. So what's cool about this is we're using comp time stuff again. We're using the type info of the struct to actually write the CSV. So the lines get dynamically populated based on the what fields we have of the struct. So if we add more fields here, or if we add basically we'll get another field here. So we'll get a new header, we'll get new fields. Or that was the case. This is in this one. We're not doing that here because it is just a little bit easier to do one alloc print. But for the header, that's dynamic. Ideally, we'll probably change that to be whatever. But I just haven't really gotten the hang of doing comp time compilation, comp time setting yet. But it's a work in progress. So we'll pull out this for the time being. We can add, remove spaces. Are we using this on non-strings at all? Yes. Let's actually remove spaces. Hold on, I'm curious. So we put this in here. Yeah, now it's going to be. We can make this actually really easy. And we can do strings dot. We have one more at line 59. Yeah, which is just the test. So strings. Yep. So that should still work. Main.strings is no member. What the heck? Line 100. Oh, strings.strings. Oops. Did too many. Yeah, so you can kind of do like namespacing like this if you want to do it in the same file. It's not really great, to be honest, but that's only because I haven't moved it to a separate file yet. Well, we're eventually going to move like some string operations over so that makes it a little easier. Cool. But now we should be able to put that also. Yeah, because I did 2 of these, so. Let's see. How's the text looking today for anyone watching? Is it looking okay? Okay, that's good. Cool. So let's try moving actually some of this to a new file. So let's start with this here. So we'll yank that, make a new file, which is source strings.zig. Strings.zig. Yeah, so you got to import standard, this, and then we should get rid of that. And then we can say const strings equals at import strings.zig. Let's see if it compiles. Okay, so that just imports the file. So would it be strings.strings? Oh, it's not marked pub. Oh, interesting. That's kind of cool. And there we go. I wonder if it'll be any slower. No, it's not. Cool. All right, cool. So that does the strings. Let's make another one. We'll do source record dot zig or records.zig. Const standard equals at import records. Okay. So we'll move this out. Oh yeah, we're gonna need I guess we can rewrite this to be a right. Yeah. That's fine. I think we should probably leave it like this rather than using the shorthand, just because like that's a little more. No, we'll pull these in just because we did do some funky stuff with them. So they are kind of like all over this. Okay, so we should be able to. I wonder if we can do this. Like, can I put a test inside the struct? Oh no, that's not. It doesn't go there. It goes here. We can change this to be run record. Oh yeah. Yeah, this is kind of a weird thing I've noticed about Zig. It has like ZLS is kind of weird on NeoVim. Okay, so let's do Zig test source strings. Okay. So it does not work. So these need to go like here. I guess I also could just do this. Like, we don't really need this anymore. Yeah. This is like more canonically Zig. What I can tell. So like then for this, we could just go up here, do this. And there we go. Okay, cool. Records. This one we're going to keep because we actually do want the run record to be like a type. Okay. Convert to Atom, Strud, Atom record, PDB reader. Yeah, let's move this out. And these are gone. So this would be like pub const. What did I delete? An extra thing here? Yep. Oops. Is it really? Oh yeah. We can move this here. All right. Hopefully today we can actually get this done, and then we can actually like publish it. We can like put it on GitHub. Atom record is not here yet. Yep. That's fine. I'll put the Atom record. I guess we can put it a little higher up. That's fine. Oh yeah, we need strings, so we'll do import there. Okay. Line.new. Yep, so we need to, this is going to get pulled out too. D, here, put that there. Parse line. This we can keep here because this is kind of like the main part of the file. So we'll do const line. Um, Atom record. Const Atom record. %s Atom record with Atom record. Cool. And then we need the run record. So const run record is that. Part of me wonders though, yeah, this really needs to, we need to clean this up a little bit, make this look a little cleaner. I mean, it is nice, all things considered. And then we can move args out too. So part of me is thinking like, do I even want to have the line accessible to the user at all? Like, should that be something that I need to import? And part of me is like, maybe not. Maybe that should just be under the hood, and then it just outputs the Atom record for you. Because we're doing that all here anyways. So what if we do that? What if we do parse? We don't need self here. We're gonna just return an Atom record. Oh yeah, we want to take this takes a const u8 line. Yeah, so then we can actually just remove this, and we can just do try Atom record dot parse, and that should work. And then we can validate this by doing like record dot to JSON, and we pass the allocator. This is probably going to break here in a second, and I'll explain why. Yep. So the advantage to this is now we can, in theory, I can make line not public, which is good. Are we using line anywhere else? Nope. Okay. Well, done. Let's go. Let's see. Expected type array list found mem out. What did I do? Oh yeah, that's not what I want at all. Oh, you have to pass it in an array list. Yeah, we're not gonna do that. We're not gonna do that right now. You can do that at a different time. But we can do. Oh yeah, because like yeah, okay. Let's do. Can I do this? Let's do record. Whatever. Let's. Cool. I know that doesn't look like a lot. Oh, how was your meeting? Move to the lower right corner of my screen. Oh man. All right, let's see. Thanks, Alcius. I appreciate it. Alerts. Chat. Yeah, there you are exactly right about that. There we go. Give me a chat, Alcius. Let's give it a test. See how it looks. Actually, I guess I could just do it. You know, I have the power here. Walk through on how to do something. Could have been an email, honestly. Yeah, I don't miss those days, I tell you what. My current job is not like that. We are very good about communication, but my last job was not as not as succinct about it. Okay, wait. Oh, we don't want to print it. Probably want to do some sort of like something. Okay. So we don't need parse line anymore. That's done. PDB reader. Good. Maybe we should look at doing a writer as well. That could be helpful actually for the next part of this project. So I guess we don't want that to be public. We don't need this to be public. I guess, right? Is that Yes, okay, that still works. Cool. We don't need that. Let's check this. Pub func. Pub write CSV header. Arguments. Yeah, I don't know if I want to move args out of main yet. I think that's kind of a good spot for it. The reader, I think, is a good spot. I think that's fine. Well, Alcius, hold on. You missed this earlier. All right, so here's the deal. We found a new file type that's even worse than this one. Well, it's actually not worse. It's actually better in a lot of ways, but it's even weirder than this one. And it's actually a more complete picture than this. So for reference, the protein database files are kind of like what you can think of as like a snapshot of a protein. But there is another file called a DCD. And like from my understanding of the DCD is that it's first of all it's a lot bigger. They can be multi-gigabyte files, so we can't read them all into memory. And they're Fortran files that kind of paint the picture of what a simulation would look like. So it has like where all of the atoms are in the system, and like also it has more information about their interactions and things like that. But there are massive files. They're huge. Like I was talking to my partner about it, and they can be pretty large. Like they can be pretty big files, multi-gigabyte files. But the thing is the PDB is like that's really cool. But yeah, exactly. So the thing is the PDB is like can be a snapshot of that. So what I was thinking was if we figure out how to do the write, what we can do is we can do something like we read from a DCD, we get that snapshot of that part, we could then write the PDB that snapshot to a PDB. But yeah. Oh, hold on. I found the coolest comment yesterday. Let's see if I can find it. Uh, formats. Hey, GitHub, can you stop trying to dox me, please? Thank you. Is it this one? I was reading through another. Is it uh transformations? No. Where is it? Coordinates, I think. DCD. Nope. PDB. I think it's here. Let's see. Yeah. Okay. You're not gonna zoom in any more for me? Oh, you did. Okay, cool. So we've seen this before, right? We know this kind of structure, right? We've seen this. This is the normal WWPDB spec, except for this part right here. Segment ID, unofficial charm extension? Question mark? Maybe? Well, guess what? This is what was causing me so many problems. Because I didn't know where to find it. It's optional, and it doesn't pop up in a lot of places, but for molecular dynamics simulations, it does. So, yeah, we found it. But yeah, this is another package. I do want to benchmark this one as well. It's called MD analysis. It's more for analytic, like doing post processing and other things on your data, more than doing the simulation part. I mean, I think it can do some of that as well, but it's more for like post processing, from my understanding. Um, and it actually does some really interesting things. So it actually reads in more lines than I do, like the header and stuff. But like, I don't even know if you can see this, but like, it doesn't even read all of the header. Yeah. But it also has a writer, so that you can like snapshot something and then write it to the PDB file. So that there is something to be said about it. Is kind of good to have some sort of writer, and the reason for that is you get the benefit of having you can like convert formats. That's kind of the thought, is like you could, if you had something that you wanted to make in a different, more viewable format, like that. So that's the thing. So when we talk about the DCD file, it's a non-text format. It's a binary file. So it's going to be a little different because we can't read in. We're not going to be able to read it like text. We have to read it in like how we were doing before, or like how I thought we were going to do this one. But it has a format where it does like it'll give you a like 4 bytes, and those bytes tell you how long to read, and you say, okay, so this is 4 bytes. It's going to be like the number, it'll be like 1,000 or whatever, right? And then you read 1,000 bytes, and then at the end of those, at the 1,001st byte, you'll get the same number again to validate that you have 1,000 bytes to read. So you have to do this thing where it's like 1,000, like 1,000, read 1,000 bytes, get to the end, check, make sure that you read 1,000 bytes. And so, like, in theory, that should be actually a lot easier for something like Zig to do, because we are already doing that in memory. So we should be able to just be like, check the amount, and then it should be a lot easier. And that way we can allocate more dynamically, which should be cool. Now the problem is, though, is like we can't do what we did here, where we read everything in and then split on new lines. But the advantage is, because it's a binary file, we shouldn't have any new lines. It's just a big block of text. So that should be the win there. But yeah, I'm going to go ahead and test MD analysis, but there's a big problem about why I can't. And it's going to require me to do some fun stuff. We can hack it in, but as you can see, it's not Nix. So we might have to package it and give that a shot and see if we can get it working. So we'll package MD analysis, I think, and get that working correctly. Even if we don't use it, it is helpful, right? Because then we have, we're helping someone out that might want to, someone that might want to do something with this. I don't know how people are going to use MD analysis. Yeah, this is the uncharted realm where Nix doesn't go. So it's actually surprising. Let me, there's actually, let's see. Is it this guy? Yes. This guy. Philip Sieber. So he has Haskell on his repo, which, says a lot. But his whole thing is he's been doing this repository. He's been working on this one, which is Nix QChem. And the goal of it is actually published to kind of show how we can how you can package things for high performance computing and quantum chemistry, which is pretty cool. But yeah, he did like a whole Nix flake for it, so you can do things like, this. So QChem you have to have a license for. So you get a valid license and it does like all this parts, and then you can do that. But the cool thing is it has like a package list, so you can like it packages a bunch of some of these like packages. You have like Gromax with MPI, which is a supercomputing thing, Gromax with CUDA, so he's really been kind of going through and actually doing this. But he seems to be kind of like the only one um, doing that. But it is cool because he provides a lot of the like stuff to like set up some of this, which is kind of cool. Yeah, Fortran 77 subroutines. Yeah, there is quantum chemistry. It if you think about it from the perspective of like physics is like the study of like forces primarily. There is a whole thing of like quantum chemistry kind of studies the how those interactions actually can work for some of this. I'm not going to pretend to know like I like say that I know a lot about like what quantum chemistry, how that differs from something like quantum physics, but it is actually a really it is studied pretty heavily, and there are a lot of chemists doing quantum work because it is at some point when you get small enough, the electron matters a lot, and that's kind of where we get to this point of like quantum chemistry kind of can do a lot of can provide a lot of that. So yeah, there's a whole lot of it out there, and especially in the high performance computing fields, right, where you need a lot of compute to do some of these simulations about quantum chemistry. But yeah, so he's kind of been doing this. I've been tracking it. I'm trying to see like how things are getting like packaged, um, to see like how this is done. I think basically he's actually like packaging them all himself and then upstreaming them. But I'm not, or not all of them. I think some of them are he's like packaging themselves and then upstreaming them. Yes, you can ask Sushi Rice about yeah about quantum chemistry. Yeah, they use it substantially, or to some extent. I won't say substantially, but at some point. Yeah, but yeah, that's really what it is. Like every time I hear quantum, I just go substitute quantum for electron. And there you go. So yeah, basically there is some work about doing packaging some of these tools um for this, and so that's kind of what I'm gonna look into. I might actually reach out to this guy and see if like, hey, this is a thing that I've been looking at. Just how would you do you have any recommendations on packaging? Or I'll probably just read the paper, and we'll see what they recommend. I'll probably start there, and then if I have any questions, I'll reach out. But that's kind of the thought here is that we can actually we'll package it. If not, I mean, for the time being, we can do something like this. So if we go to we can always do which pip python -m pip. Don't I have pip installed? Um, flake.nix. Let's take a look. Yeah, so we can do a flake here, and I think we could add Python 3. Let's take a look. Let's see what's going on here. Yeah, Python 3.11 pip. Let's watch my freaking storage space just disappear into the ether. Yeah, I hadn't cleaned my Nix store in a while. So the other day I opened it up and it was 100 gigs, and I was like, "Oh, it's time to clean that bad boy up." Um, okay, so which pip? Yep, there we go. So we could do a pip install. I think we should be able to do this. Let's see. MD analysis. This environment is externally managed. Let's try us to modify the immutable Nick store file system. Well, oh, I forgot they added this. Oh man. Uh, ad hoc temporary shell. Can I just do? Interesting. Can I just do with packages? Let's see if any of these are not. So is tools. Yeah. So my concern is that these are all things that are actually in here. It's free real estate. That's right. That's right. With packages. Wait, you could put Nick's shell stuff in the shebang? That's actually really sick. That's really cool. Um, okay. Uh, is libffi? Okay, so that's not a Python package. Python env. We begin with importing the next package collection with packages, functions, an argument that calls for return of packages to include in the environment. Here we select NumPy and tools from the package set. Um, yeah, so let's try that. Mvim flake.nix. All right, so Python env equals. Yep. I don't need pandas. I don't need SciPy. I don't need NumPy. I do need polars. We can get rid of pip. Let's try this MD analysis. So we should be able to do Python env. Oh, so this needs to be a .env unused. We'll leave that in there. Nix develop. Let's try native build inputs. Oh, I guess I could do this. So it would just be like packages equals. While evaluating native. Yeah, that's not what I wanted. Flake.nix. Yeah, I think that. So what if I get rid of this? Yep. Okay, so I think we'll have to package that. Which, like, honestly, shouldn't be too bad. Like, I was looking at that. Issue tracker, quick start site, install is a way to do this here. Yeah, this one we can. It's creating a development environment. So I think what we would do. All we have to do for this is we just need to make sure we have these dependencies because we're basically gonna build it from source. I think is really that. There might also be the potential to just pull in this and then that, just install it. But we'll just get the git tag for it. I wish I could just like do this. I understand why I can't, but I think we should just be able to get prayer production should be handled by the release manager only. Okay, so let's take a look at that. So in theory, we should have a package dash 2 dot. What's the most recent release? 2.6.1. So I should be able to go like packages 2.6.1. So then I can pull in the latest one, and then we just go, what is it, package branches, yeah, pip install Jupyter Lab install Node.js. Nope, thank you. E package. So all we'd have to do is like install this here in theory. But yeah, well, that's a project for a different day we'll get into. We're not doing that today because we care about Zig here. We're doing Zig first. Oh, I forgot to show you this too. So I wrote a script so we can do nix develop Python analyze.py. Pops out a bunch of graphs for me, or things for me. So this is using polars, which is like a Rust alternative to pandas. And we have things here like the Zig. So this does the arena validation. So this shows like a lot of the counts, the null count, things like that. This shows our coefficient of variation. So that's kind of showing how close together your standard deviation is to your mean, basically. But yeah, so like on average, this is the normal Python one. That's like 6% here, and then we also have like a standard. The mean time is 3.3 seconds. This would be on Zig. It's a mean time of 0.2, and then I got it down as low as 0.16. And as you can see, like this is 6.2 and 6.2. So basically, the idea is the closer you are to 0 on that coefficient of variance. So you have to take this as a percentage. So the closer you are to 0% is the closer you are to basically like, in theory, maximizing your runtime, right? So like that would mean like I can't really optimize much further because like my average time is matching pretty much my standard deviation. So that's pretty good on the arena allocator, which is just kind of a win. Gives us a lot more consistency, and the reason for that is we allocate that whole page or that whole chunk rather than like doing a lot of little allocations. So we have way less more I/O, and we just like allocate a bunch all at once and then free it all at once. So that's a win. I think this is looking good. We probably should add a way to like print these out just so that we can validate it. So let's try and hack on that. Pub func print takes this. It's going to return nothing. Let's see. Standard dot. Let's see. Yeah, let's give that a shot. main.zig. Do that. Let's make this a lot less because these are pretty big. This is going to be a lot. I think I have a small one. Let's do a small PDB. So that's 1T. Why is it a constant? I think there's an iterator. Oh, can I do that? Can I just do? Oh, invalid format string F for type F32. Copilot. How do I print? Oh yeah, because it's like just this. You're just not going to print anything? Oh, because it just runs one. Okay, so all we have to do is this. There we go. Is that right? One T 27Y PDB. That's not exactly right. What is going on here? Residue name is a 1? That doesn't look like that adds up. That should Yeah, that's weird. Let's make this a little more let's make this easier to read. We'll just do record serial self dot record self dot serial. Yeah, that's not right. It is reading the right number, but the record name is that should be an atom. Is this happening again? I think it's. Do I need to dereference this? All right, let's see. Nope. Uh, this is the same issue I was running into before. So you can validate it. Yeah, let's do this. So cool. Okay. This is probably going to let's try this. In theory, this should work. Get atoms at 0. Nope, not there. Atoms at dot items at 0 dot print. Okay, fine. Thank you. Yeah, see, that works. So it's because we don't own it that it's failing. Yes. Let's take a look. Iterate zig array list with the for loop. Oop. Let's get rid of that. Hold on. Iterate zig for loop. I found Reddit to be not super helpful for this. I don't even know. Let's see. Because I feel like they've changed the for loop stuff like 4 times now. And it's just like, it's very weird. It changes on a new record. I was about to say why the Atom record. So it doesn't, or it shouldn't, I don't believe. Because the PDB reader is a array list of this. So Atom record. So let's just for const up here just says that the too niche for the topic for Reddit. Yeah. So what happens is it's like I've read it on Reddit a couple of times where like it doesn't really like line up because they've changed the API a couple of times now that like Reddit, and also the Zig team isn't even on Reddit anymore. They have something called Zigit because of like all the stuff basically like uh all the stuff like there like that happened with like the Reddit whatever. They kind of moved off of it and moved to this thing called Zigit instead. That they kind of put together. Which is fine. That's not a bad thing. But yeah. But let's see. So let me just stress something. This does not mean that an Atom record is constant. It means that the import is constant. So this is like basically saying like this keyword is constant. This is not a variable though. Basically what's happening is that here, so let's see. So if I go here and no, it's not here. It's down here. We get this. For that's a const. Is there an array list? Yeah, so I wonder if it's just this. We want atoms for atoms. It's not this exactly. It's like a pointer to this. Yeah, no, that didn't work. So here's what happens, and this is what I've been running into. Let's think about this. Let's see. Um, so what happens is basically that this string, which is so the strings are constants because they're which I don't know if that's the best way I should have done this, but that's what we're doing here. So the strings are constants. Um, but what happens is that the memory sometimes gets a little weird. So that should be fine, but for some reason it's not. So like if you notice, what happens is if we do, if we read a single one, that's fine because we're directly accessing its memory, right? And we can keep doing this. So if I do like the second one, it also does it. It'll be fine. Oh, maybe not. So let's move this. We can go back here. All right, let's see. Yeah. No. It is. It can be kind of weird to read. I understand. I have a test for this somewhere. So let's try. Okay. Let's write a test. Convert to atoms multi-line. We'll do this. This is going to look gross. We can okay. There we go. Um so standard how do we do this here? We parse multiple lines, so I think that's here. Read to end alloc. That's not really what we want here. How do we do it here? So we read to end, we pass it to the reader. Yeah, that's what we want. So we'll do this. And this actually a really cool thing is there's a standard.testing.allocator. So you can it's a deterministic allocator, I guess is what it could be referred to as. And then we do this. And we just do a split sequence on lines. It takes a constant. For uh, um, let's start with that. Source records is not indexable and is not a range. Oh, dot next. That's an iterator. Huh? So what is the split then? Is it? Oh, it's a while loop. Yeah, the whole while versus for syntax is kind of weird. I don't really. Ah, so it's not 2. What's its length? Oh, it's because it's items.items.length. And um oh yeah, we need to free it. So okay. I wish there was like a better way to do testing than this. I don't like this whole like try. I mean, I understand why they do it. I just don't love it. Let's do this as well. Because this is what we're interested in. Is it record? Yeah. Yep. Yeah. Okay. So that makes sense. So this will validate one thing. It's going to validate where we're losing the data. So I think if it's here, so if we go up here, let's try this. Standard.debug.print s\n record dot name. No, what were we printing before? Was it record name? Oh, we were just doing an atom.print. Okay, so we should be able to do that here. So yeah, we should just be able to do record try record dot print. Huh? What? So we call the PDB. Are we calling the PDB reader here? Yes. Go to definition. Yep. Let's go here. We should have a self.record and a self.serial. Oh man. Okay. Let's go all the way up to 1. Does 1 have it? No. So yeah, it's not printing anything. Darn it! I thought I was so close. This keeps happening. I need to really figure out what's going on here. Parse. Because if you look, we have it. We don't lose it here, I think. Um, so if I go here and I go atom dot no standard dot debug dot print. There we go. We print that. We do have it at some point, and then we lose it. So we go here, we check this. Let's see, is this deinitializing anywhere? Because generally what's been happening is that when I pass the reference, it tends to fail. Let's try this. Yep. So we do have it at some point. It's just that when we get it back, should that be a reference that we're appending? Let's see. Atom.parse. This should return probably. So this is returning a atom record. So let's try something. Go to definition. We will var atom equals try. Yep. Standard dot debug dot print. Return the atom. So let's see if this works. So we should get a lot. Yep, it's not working. Yep. See, so the strings are not. This makes sense. These are empty. That's good. But the element we should have, and this should be this. Hold on. This might actually be okay. Let's see. Let's try this. Yep. Yep, there it is. So let's try this again. Oh. What? Okay, that doesn't make any sense. That is making no sense. I don't know. So we're getting a weird slash, but if I go back to parsed, it works completely fine. Okay, so I think it's a memory thing I need to figure out. It could also be a Zig thing, though. That could possibly be the case. So what if we return a reference? Expected bound here. So it's just because of this. We need to return a reference to this. Zig is not production ready. Correct. It is not. I would not say that it is. And I'm kind of surprised that Bun used it, actually. So do we have to dereference the pointer then? There it is. Oh. Can I just... Oh, okay. So let's do this. It should be a pointer. Oh, no, no. If it was... Not me telling you I didn't know if it was... Oh, no, no, I know. No, I got you. Type info. Oh, okay. Okay, so I'm gonna revert some of these changes. We will come back to this. I do need to get the print working. I know that it's like it does it right once. Which is, famous last words. What if we do it here? Like try record dot print. I wonder if it's just like when we insert it, does it break? That doesn't really help me. No. Okay. Yeah. I know that it does parse, but I just know that it doesn't parse correctly. But all right. I think it's that time of the day. I think it's time to bring us into a raid. I think let's see who's on. Uh let's see. I don't even know who's on today. Oh, uh I did mean to show you this. Appreciate it. Thanks for stopping by. I do. I know you have your choice of you have your choice of streamers and you choose me this morning, so I appreciate it. You do have a surprise. I have something coming up for Thursday. It's gonna be fun. We're gonna get getting a green screen back here. It's gonna be fun. Uh, we'll see if it works. Let's see who's live. Is he? Yeah. Let's let's do that. And all right. Raid. Yeah. So we'll do Berserker Brooks. He's a cool Rust guy. Would recommend. But all right, cool. Well, thanks for hanging, and I'll see you over there.